Hello and welcome to a Redstone tutorial. Now, have you ever wanted to lock your goodies away in Minecraft? Have you ever wanted to keep them under lock and key, keep them safe? Well, this might just be for you. So let's take a look at what we've got here. Well, we've got 4 torches in those item frames, and I'm sure you guys have seen the title. You're going to know what we're going to do. We're going to spin them around. I've just set the code to be this, which is going to be very easy for me to do quickly, and the door opens. We can go through. And there we go. There are our goodies. We've solved it all. Now, this is the back panel here, and it is going to be setting what the code is. So, for instance, if I change this one, I just put it to be there, you can see that the door will close, and you're going to have this code now. It's important to note that this is reversed, so they will correspond directly to the panel that is opposite them directly on the other side of things. So this change will correspond to this torch here. So if we change that one, again, you can see that it opens. And if you do go through, if the code then changes on the outside, you will be able to get out because I've set up this button here. There's a little customization there, but let's get into how we make it. Well, the core concept of how this design has been made is to do with comparing signal strengths to each other. And the way you do that in Minecraft is with comparators. Now, you can see I've got these long lines of redstone and the ability to put a torch next to them. This is just so I can change the signal strength of the redstone going in. On my texture pack, on my resource pack, you can see I've got numbers set up on the redstone dust itself, which means you can see exactly what the value of the strength is. Redstone dust obviously going from 0 to 15 signal strength, so this is a maximum signal strength here, and it goes down to be 6 just before it goes into the comparator here. I've got it set up as the same position going into this other comparator, and they are going to feed into these 2 torches, powering this line, and these lamps just to indicate what's going on. Now, because they're the same, these lamps are off currently. So if you see, if I break this torch, they are going to go on, and if I put it in a different place, if I put it closer, it will be staying on as well. If I keep it at the end, obviously that torch is overriding that one in this situation. But if I put it at the end, you can see that the lamps stay on, and they are going to be dictating that these 2 comparators are receiving different signal strengths. So that's 6 and that's 4. Now this works by the comparator taking an input from one side and putting it into the side input of the other comparator, which means that if the signal strength going into one comparator is greater than the other comparator, it will actually just block it off completely. Because, of course, if you have the 6 going into the side of a comparator compared to a 4 going into the back of it, that's going to just stop that signal. Make sure it's not on subtract mode. You can see those lights are going to light up. It will look different on your resource pack depending on what it is, but the general theme should be if the light is off, then you are good. This is going to block it both ways, and of course then these 2 torches will turn on or off based on these 2 comparators. This line is taking power from both of these 2 torches, and that will turn the lamps on and off. Of course, if it is the same signal strength in this situation specifically, the lamps will be off, but you can very easily change that to be on by putting a bit of redstone here. And you can see that this wire will be off, and if they're at the same position, then it will turn on. So that's the core concept. Let's see what we can do with it. On this specific design, it uses this very small version of that machine over there. It doesn't take the output just yet, but we're going to be getting into that in a moment. And you can see on this side, I've got an item frame as well as on this side. You can see that they are giving currently the same signal strength output because, of course, item frames in Minecraft, certainly as of 1.16 when I'm recording this, do give out signal strengths when a comparator is placed on the block behind them. Now, of course, these are the same, which means that both of these lines are lit. And so we're going to be trying to use this fact to create the lock that we saw earlier. Of course, you can change it like that. You can see now they're different. So one of these lines is lit. Only this one. This has a 0 signal strength. This has 2 because that is in the 2 signal strength there. So if I change it to match, again, they'll both be on. And if I change this one, you can see that only one of them will be on. So if they're different, one of them will be on. If they're the same, they will both be on. So you can see now they're both there. So let's scale that up. I put 4 of them next to each other, and I've had to do this little fancy staggering here Of course, that's just to stop this wire going into the side of this comparator, which would mess with the rest of the contraption. So you are just going to have to bear with the staggering situation here. Of course, the item frames still as they were, but what I've done is add torches on the side here. So when this redstone wire is lit, this torch will turn off. And the same on this side. Now, it will be passing power down to these lines here. You can see all the torches on this side will be passing their power down to these lines here. So this torch will be powering this bit of redstone dust. This torch will be powering this bit of redstone dust. And then you can see that runs all the way down. So whenever this piece of redstone dust is powered, this torch will be off. And if all of these consecutive redstone dusts are off, or on, sorry, then all of these torches will be off, which means that this whole line will be unlit. But if just one of them is wrong, you can see that the whole line lights up. So you have to make sure that they are all correct and all the same as the other side. We use the same logic on this side. You can see all 4 of those torches are off at the moment. And if I make it wrong, then you can see this torch lights up and that whole line gets lit up as well. So what we need to do is make sure that both of these lines are being taken into account when we want to know if our combination is correct. You can see that they both currently match. All of those torches are the same in this machine. But if we were to change, say, this one and this one to be different, then you can see both of these lines are lit up. But if we change it to be just this side is different, then just this line is lit up, which means that we need to have a connection between these 2 lines. And you can do that in whatever way you want. You could put torches on the side and have that powering some redstone here. Or you could take repeaters off these 2 lines and do it that way. But it's really up to you. As long as you're taking into account both of these lines when you're powering whatever device you want this combination lock to be taking into account. Another great thing about this design is the fact that it's stackable. You can put them next to each other, repeated over and over again. So if I just stack this once, you can see here that now it's just added another 2 on. I've just copied exactly the same design next to each other. And you can see now that they are also being taken into account. So again, if these are different, then one of these lines will light up. If they are the same, then they'll both be off. And they're all still counted here. Now, you can do this for as long as you like, but you have to remember that the signal strength from one end needs to reach all the way through. So, for instance, if you were using this end as your output end, the signal strength from this torch would need to reach all the way down there. So you can measure that by putting a torch there and seeing where it would run out. So if you do go over the end, you can see that at this point, you would need to add in a repeater. Should be simple enough. You can just plonk a repeater down anywhere where there isn't a torch above it. So, for instance, if you just wanted to put a repeater here, that would boost the signal strength along. It will add a little bit of delay to the system, but if you're making a massive system, you can certainly take the hit on that most often. Because, of course, you'll probably be able to get to, I think, 8 of these modules before you need to add in a repeater, and that should be plenty for most people's use cases. And you can see there again, we just have that signal being boosted through. It's important that the redstone dust stays on top of this block because it's taking power from this torch and can mess things up. It will remove one of the modules here from being part of the circuit. So make sure that you have all of that redstone dust everywhere where there is a torch. Now, that design over there has a couple of flaws in terms of its design capabilities. First of all, you can see that the torches themselves in the item frames are staggered, as well as this torch right here being right next to the potential input panel, which means that if you're building it into a build, you'd actually have to sort of sync it all in like this, and it doesn't look the greatest. You want to be able to see all of these torches at the same time rather than having to see any of the extra panels and moving along at the same time. So what we've done here is extend them out just a little bit and keep that staggering going. One up, one down, one up, one down. This is going to be useful because it means that we can create this fully flush wall where it looks fantastic and clean. And you can put whatever designs you want on there and make sure that it looks all nice and presentable, just like we have over there. So with this extension, what I've done is take a comparator out of the back of the item frame, put it into a single piece of redstone dust into the back of our signal strength comparison comparator circuit here, which means that there is no drop in signal strength from this item frame to this comparator. So it's basically just moving the signal strength from this item frame all the way into the same setup as we had over there, which is fantastic. Big fan of that. Right, so now that we've got that out of the way, you can see that it's the same on the other side. We have to drop those signals down to these control wires, and this is where I've merged the two. I've opted to go like this because I didn't want to have it go any further than the end. So I've pulled repeater signals out of those wires and into a torch. So you can see at the moment the two combinations are matching, which means that this lamp will be on. But if I was going to change one or something like that, that means that the lamp would turn off. So you need to make sure that they are all the same. Oh, I have to go around again until they turn on. And that would power your door, power your piston door, power whatever you're trying to protect from any ne'er-do-wells. So all you need to do there is bung it in a box, put it next to a door, and Bob's your uncle. You have yourself one secure vault. So there you have it, a fully functional item frame combination lock that is stackable to any length. Fantastic stuff. It's only 2 wide. Looks pretty nice, looks pretty clean. Of course, this is a very bare bones build. You can design around it however you like, incorporate all sorts of design elements, but underneath it all, it's pretty simple to build. So hopefully, you guys are going to be able to keep your stuff safe from all of those ne'er-do-wells roaming around in your multiplayer servers. Have a good one.